Hello friends, how are you all? I hope you all are studying very hard and preparing very well. So welcome to the fifth module on extension education, and today with the unit which we will cover is a very important unit, research methodology. So we are going to cover the important topics on research methodology. So research methodology is not only important for your preparation, but it's also important to become a good researcher. So we will look into the important topics of research methodology, and I will try to make you understand important topics on research methodology. So it will be beneficial not for only students of extension education, but also students for other disciplines also. So these are the four important books which we should consider and which we should refer for our research methodology unit. The first and the foremost, the most important book on research methodology is Foundation of Behavioral Research, written by F.N. Cullinger. So this is a wonderful book, though you will find little bit boring because it do not have colored pages. Many questions are based on this book. So this is the first recommendation on research methodology, Foundation of Behavioral Research by Fred and Cullinger. The second book, which is again a very wonderful book, written in a very simple manner and easy to understand, and written in a language which students can understand easily, is Research Methods in Social Sciences and Extension Education by G.L. Ray, Sagar Mandal. So the notes which I will show and the topics which we will discuss will be based on, because I have prepared my notes from these two books. So you will find good quality images in my PowerPoint presentation of my written notes, which are prepared from these two books, Foundation of Behavioral Research and Research Method in Social Science and Extension Education. So if you read these two books line by line, and if you are able to extract important topics from these two books, then you will be able to handle each and every question which comes in ARS mains exams, and also you will be very strong in your research methodology. There are certain very good books other than these two books. They are also very important. So now if you are preparing for ARS, you can read Foundation of Behavioral Research and GL Rain Sagar Mandal book. But if you want to have good knowledge on research methodology, so there are certain other books. These are, first one is Methods in Social Research by William J. Good and Paul K. Hatt. It's a wonderful book if you want to have a good command on research methodology. So Methods in Social Research by Good and Hatt. Another book especially focused on researches which are being done on education. So it's again wonderful book, especially the research models, the designs are explained very wonderfully with examples. On this book, Research in Education by John W. Best and James V. Khan, Arvind Kumar Jha. So this is again a very good book, two important books which you can refer if you want to have advanced knowledge on research methodology. Otherwise, two books, Foundation of Behavioral Research and Research Methods in Social Sciences and Extension Education, are sufficient for preparation of ARS examination. Another book, C.R. Kothari book is there. Kothari book, generally focusing on statistical methods and sampling, that you can also refer with advent of time. So let's start our session. So today in this module we are going to cover science and common sense. We will start from here. So you will find this is the first chapter of Cullinger, science and common sense. What is the difference between science and what is common sense, and how they are differentiated with each other? We will look into it, science and common sense. Then four methods of knowing. Generally students who do not read Cullinger, they will not be able to answer these type of question, and sometimes 5-mark questions come in ARS where they generally ask what are the important methods of knowing and who gave them. Objective questions can also be framed from here. So we will look into these four methods of knowing. Then we will look into what is the aim of science. Then we will try to understand what actually research is, what is the definition of research, and then we will look into what are the important features of research, characteristics of research. Then we will discuss types of research. So it will take long time, so in next module also I will explain. So in today's module, within type of research, we will cover experimental research, mainly laboratory experiment and field experiments. So let's begin our session. So the first topic is science and common sense. Vigyan or common sense. Science and common sense. So science and common sense, you already know many things about this, but focus on this line. Science is a systematic and controlled extension of common sense. It means that common sense gives us idea that this is the cause of this effect. Suppose some experiment or some event has occurred. Now you will first apply your common sense. How common sense will be built? Common sense is built with advent of time, on the basis of your social interaction among your parents, among your peer groups, your upbringing, your knowledge, your IQ, your schooling. They all contribute to a common sense. We can say the informal education which we are getting with advent of time contributes to our common sense. Now, when an event has occurred, first human being will apply common sense. They will try to explore this has happened due to common sense. But common sense do not give you the exact reason. It will only give you speculations. It will only give you directions. When common sense is studied systematically, and how it will be studied systematically, we will look into it when we will study the research design and how experiments are framed. When we look into the variables, when we look into the control of any design, then we will look how systematically we can design our experiments. So when common sense is looked systematically and in a controlled manner, means we are controlling certain factors so that we can see the effect on certain other factors, then the common sense will become science. So that's why science is a systematic and controlled extension of common sense. So without systematic and without controlled extension, it will be not a science, it will become only common sense, and common sense are generally not accepted in research area, right? Because common sense can give you wrong conclusion also. It can be true, it cannot be true, but when it is systematically and controlled and studied in a very specific manner in a research design, then we can say that we are practicing science. So always remember, common sense and then systematic and controlled extension of common sense is science. So Whitehead has said that in creative thought, common sense is a bad master. Why he has said that? Because whenever event has occurred, now researcher will apply his or her common sense, and if the scientist is drawing conclusion on the basis of common sense only, then he or she can conclude wrong. That's why when you become creative, when you are going to investigate a particular problem, when you are practicing science, then common sense is a bad master. It can lead to you invalid conclusions. So it has to be studied systematically in a controlled manner. So always remember, Whitehead said this: in creative thought, common sense is a bad master. Suppose sometimes this question can come, that in creative thought, common sense is a bad master, which who has said this, right? So Whitehead has said this. And always remember, science is a systematic and controlled extension of common sense. Now, how science and common sense differ in 5 ways. So they can ask a 5 mark question that differentiate between common sense and science. So the first difference is, in science, conceptual schemes and theoretical structures are different in both science and common sense. How they are different, we will look into it. In science, scientists systematically and empirically test his theories and hypotheses. Yes, in science we have certain variables we control, certain variables we want to see effect of independent variables on dependent variables. That's why we control certain variables. And then after controlling certain variables and then designing our whole research systematically, we draw conclusion based on rejection and acceptance of our hypothesis. So this practice is science. We do not do this practice in common sense. That's why common sense is not systematically and empirically studied if you want to draw conclusion on the basis of common sense only. So no systematic, no empirical evidences tests are done in only drawing conclusion from common sense. When you systematically and empirically involve theories and hypotheses and study common sense according to it, then it will become the practice of science. So scientific research involves control. Only common sense do not involve control. In science, scientist is preoccupied with relations among phenomena, while in common sense, preoccupation with the relation is loose, unsystematic, and uncontrolled. So common sense is just a common sense. You have speculations, you are drawing conclusion based on your experiences only. When you systematically and empirically study it, it becomes science. So there are different explanation of observed phenomena in both of the cases. Now please note, metaphysical explanation. Sometimes you will find an objective question that what is metaphysical explanation. So anything, any proposition which cannot be tested, it becomes metaphysical explanation. For example, if I say that God exists, it is my firm belief. When we will discuss 4 methods of knowing, then we will discuss it. If I say that God exists, it is my belief. Other person says no, God do not exist, but we cannot test it. How we will design an experiment to test whether God is there or not? So it become a metaphysical explanation. So anything which cannot be tested, based on the practices of science, then it is metaphysical explanation, right? Suppose there are many theories, conspiracies regarding unidentified flying object, UFOs, right? Many people claim that they have seen UFOs, and the way they describe the phenomena, we cannot test it because that event has already been occurred, and it has been occurred beyond our control of variables. So metaphysical explanation. Or anything happened to anyone, for example, there are certain superstitions that ghost has appeared into the body of some persons, and they are trying to prove it scientifically, and that cannot be tested. Again, metaphysical explanation. So metaphysical explanation means any proposition that cannot be tested, it metaphysical explanation. Now, four methods of knowing, very important. There are four methods of knowing what has happened, what are the factors which has caused to this effect. These four methods of knowing are also known as fixing belief. So you can find a 5 mark question, four methods of knowing or four methods of fixing belief. So these four methods of knowing were given by Charles Peirce. Okay, I have written, you can note down the spelling, Charles Peirce. So what are those four methods of knowing? The first method, he says, is method of tenacity. So what is method of tenacity? Method of tenacity says man hold firmly to truth because they always known it to be true. Like, for example, there are certain superstitions that man has certain beliefs. For example, if a particular cricketer says that whenever I put my left pad first and then right pad afterwards, I score more in grounds. Again and again he has tested it. So again it is becoming true because it's a just coincidence that it has become true, but it has formed in that personality of cricketer as a truth. So he will always put his left pad first and then the second right pad afterwards. So for example, Sachin Tendulkar, I was seeing one interview of Sachin Tendulkar. He always says that I have a habit of putting my left pad first and then right pad afterwards. Whenever I have done this, I have scored more. So it is there is no cause and effect relationship, and we cannot test it. How we can test it? It is just a belief of a person, and it has become truth for that personality. So it's a matter of tenacity. So it's not a good way to analyze the situation, and it will not happen again and again. We cannot draw valid conclusion on the basis of method of tenacity. Then comes method of authority. Method of authority says if something is documented based on certain reliable sources and it is penetrated among societies, so society and people will believe that it is true. For example, if Bible says it, it is so. If Ramayana says it, it is so. If Mahabharata says it, it is so. If it is written in our ancient literature, it is so. So people always method of establishing belief that if something has been documented systematically in past, then it will be true. People believe that. So PSC says that this method is superior than the method of tenacity. Obviously, method of tenacity is just becoming very nearer to common sense or very nearer to past experiences based on very particular individual experiences, and method of authority is little bit advanced because earlier there has been some documented, and those person who has documented those documents has done lot of research and lot of insights, lot many great personalities, stalwarts has given those literature. So many things are right in those literature. So method of authority is still better than tenacity, but again it is not 100% correct, or even if it is 100% correct, we cannot test it, right? So human progress can be achieved on this methods. So method of authority example is it is given in Kallinger book. If Bible says it, it is so. It is written in our NCRT history book, so it is so. So this is method of authority where past references are certain documented literature. Now comes a priori method. Many times you have seen this question. Many times we have seen this question, but we have just mugged up the concept because this we want to solve the answer in examination. But now understand it. A priori method, Cohen and Nagel called is method of intuition. Right? Method of intuition, and you already know the meaning of intuition. Intuition means something I am saying because I am just feeling it. This is intuition. For example, the most appropriate example is, suppose you went to a doctor will see your symptoms, and on the basis of symptoms and on the basis of his vast experience, he can give an intuition that, oh, this disease is looking like pneumonia, right? And now you go and test. Doctor is around 90% sure that this can be pneumonia, but once you will do your test and test will show that yes, this person has pneumonia, then he will 100% sure that you have pneumonia. Now you go for medication, he will prescribe you drugs, but before giving you medicines, he himself has said that it looks like pneumonia, it is my intuition, right? Certain critical operations are there, doctor has to take a decision. So on the basis of intuition, and from where this intuition will come, this intuition will come from the vast experience. For example, in extension situation field, if we are running a project in a village and certain mishappening has been in village, then a good extension worker, based on his vast experience and based on intuition, takes some difficult decisions, that today we will cancel our village seminar because this has happened in villages. We will go because my intuition is this: if we will organize this village seminar, then these things will go wrong. So method of intuition, it happens to anyone, and you also have witnessed there, and we also have witnessed an intuition. So we also speculate based on our experience. So what is the difference between this a priori method and method of tenacity? Method of tenacity is particularly based on your personal experience, but method of intuition is based on your vast experience, and those experiences has been speculated, those experiences has been accumulated based on certain experiments, because experience has been accumulated based on certain valid conclusions drawn on past. So based on those experiences you are taking here decision. So it is self-evident and priorized, and it is given by Cohen and Nagel has called this method of intuition, and a priori method given by Charles Peirce is a third method. Now coming to the fourth method and the most valid method, which is known as method of science, which we will study in Kallinger book and GL Resagar Mandal book, which we all are practicing in research, National Agriculture Research and Education System, in CSIR system, in all the scientific fraternity across world. This method of science is going on. And what is method of science? So we will dedicate a whole module. We are dedicating this module only to that method of science, where objectivity is there, where self-correction is there, when you are studying a phenomena systematically based on scientific method, based on variables, based on control of variables, based on approved ways of doing the things, it becomes method of science. So of these all four methods, which method is superior? Method of science is always superior, right? But it is always debatable. Many people debate that where science ends, religion and other things will start. So these all are the debates which happening between science, between religion, between science and between metaphysical explanations. So we need not to go into those debates, but according to books, according to our textbook, method of science is superior because we can test it, we can test it, okay, we can prove it. So these four methods of knowing, please note, and please try to understand, and these are the notes. You can directly make your notes from here. I have made these notes from Kallinger book. Okay, so now science, you all know, it has a static view, it has a dynamic view. Many scientists have seen science as a dynamic view because it's ever changing, new discoveries are coming again and again, and old theories are becoming redundant, people are proving new theories. So it's a dynamic process. Sometimes it's look like a static process because certain laws in science are always static, they are not going to change, like law of motion, like gravity law, they are will be always there. So it's a body of facts also. So that way science is a static, and when new theories are coming, that's view, science is a dynamic process. Now there is a heuristic view. I have clearly written, present state of knowledge serve as a base for further scientific theory and research. This is called as a heuristic view. Heuristic view. Okay, so whenever it comes, a heuristic view means we are adding to the present state of knowledge, so we are enriching that present of state of knowledge. So this is a heuristic view of science. So now what is the aim of science? उद्देश्य, हमारे विज्ञान का उद्देश्य क्यों है? Why there is a so great network of scientists in our country, from the past whole world has witnessed so great scientists, and why they all are practicing science? Because the basic aim of science is theory. This is the classical objective question which can come from this part. The aim of science is to build theory, that is to explain natural phenomena. Such explanations are called as theories. Basic aim of science is not the betterment of mankind, it is theory. So better of mankind is the consequences of a good theory. Like Newton has given his theories, like gravity has been discovered, Einstein has given its theories. So if we have harnessed those theories in a good way, then it will do betterment of mankind. If you are not able to harness those theories in a good way, then you have all witnessed how atom bomb has destroyed the whole Nagasaki, right? So you, how you are using those theories, it's depend on the deeds of mankind and thinking of mankind. But the aim of science is to develop theories. So what is theory? Again, please note, it's a very basic question, and it will also help you to do a good research work in your MSc and PhD. So what is a theory? A theory is a set of interrelated constructs, concept. So what is the difference between construct and concept? We will look into upcoming modules. So construct is different from concept. So please note these two terms, constructs and concept. We will discuss in upcoming modules. It's a set of interrelated construct and concept definitions, propositions that present a systematic view of phenomena by specifying the research methodology, research design involved in that part, right? So here you please note that systematic view. Systematic view means you have a valid method of measuring a particular test. You have a well accepted, well proven research methodology where you are measuring certain concept, constructs, variables, and you are doing according to the rules of science. Then it will create a theory. A theory is a set of interrelated construct concept, right, which has been studied in a systematic view. So please note down this definition from here. Okay. So now what is scientific research? So scientific research is systematic, controlled. What you are controlling? You are controlling the variables. Which variable are being controlled? We will discuss when we will discuss the research design. So please here you note it's a systematic, controlled, empirical, based on certain data which can be counted, which can be tested, where research methodology, different models can be executed, empirical. And critical investigation of hypothetical proposition. Hypothetical proposition means, you all know what is hypothesis, right? So when we are reading, when we are analyzing, investigating a particular research problem, then we build hypothesis, two hypotheses, right? You all will we will discuss it when we will discuss the hypothesis part. So we will test our hypothesis. So you all know we make null hypothesis and alternate hypothesis, and one hypothesis will become true, other will become will rejected. So we will test that hypothesis. And what is hypothesis? Hypothesis is the relationship between variables. There are independent variables, dependent variables. So the relation between these two variables is being framed for framing the hypothesis. We will test it. How we will test it? We will test it through our systematic, control and empirical critical investigation of research design, and then we will test the hypothesis about the presumed relation among natural phenomena, and then we will conclude, oh, this has happened due to this. For example, if I say if the temperature increases, then this disease infestation is more. This is my problem which I am studying. So I will control my temperature. I will see the effect of temperature on my pest population, and then I will control. Yes, if temperature increases, then pest population increasing. If temperature is decreasing, pest population is decreasing. How I will conduct this experiment? Based on certain valid models or machinery available in my lab. So it becomes systematic, controlled, empirical, and then I am studying a natural phenomena, and then I am drawing certain conclusion. Then it's become a scientific research. So Dewey is another scientist. He has given reflective thinking, how we think, right? He has given an analysis of how we think, because this all whole process which we are discussing is the thought process of ours, right? So to boost this thought process, to give a systematic direction to this thought process, we are doing scientific approach. So scientific approach consists of problem, obstacle and idea. Yes, without problem you cannot start your research. So there should be a problem. So what scientific approach consists of? First, problem. Second, a hypothesis. You will make an hypothesis. How hypothesis is being made, how it is being rejected, how null hypothesis and alternate hypothesis are being framed, we will discuss later on. So here I have just given a definition of hypothesis. So hypothesis is a conjectural statement, alternative proposition about relation between two or more variables of phenomena. So there are certain independent variables which are affecting our dependent variables. We are making a relationship between these two variables, and then we are testing it. So it is hypothesis. We will discuss it more when we will study our hypothesis in upcoming module. Then there is a reasoning and deduction, right? From our research we will reason it, why this result has happened, and then we will deduce it, right, for so that it can be generalized for other areas. Then we will have a observation test experiment. It is again a scientific approach, right? Now I have written in black pen, we do not test the variables, but we test the relationship between variables. If I am looking the effect of temperature on pest population, I am not actually testing the temperature and not testing the pest population. I am testing the relationship between temperature and pest population. When temperature goes up, what happened to my pest population? So the relation between these two is studied under this model. So these are the characteristics of scientific approach. So till now what we have studied, till now we have studied four methods: science and common sense, four methods of knowing: method of tenacity, method of authority, a priori method, method of science. Then we have seen static and dynamic view of science, heuristic view of science, aim of science, definition of theory, scientific research, and characteristics of scientific research. Now coming to research. Okay, now we will start. What is research? How it is defined? So okay, so research refers to the search of knowledge, right? Its name, if you bifurcate the terms, the alphabets in research: research, we are searching, again we are searching knowledge, that's why it becomes research. So what is research? Sometimes you will get a good question of 5 marks: research and its features of research. So research is a scientific and systematic investigation of information on a specific topic. Good definition. I think I have compiled this from GL Ray and Sagar Mandal book. So research is a scientific and systematic investigation. It's scientific because we are using valid scientific model, systematic because we are going step by step of information, right? We are having certain variables which the data which we have collected, that is information. So now that information we are assessing scientifically and systematically on a specific topic, it becomes research. So now what are the important features of research? The first feature: the research is directed towards the solution of problem. The aim of research is to solve that problem. Suppose as an extension scientist, I have seen certain problem in a village, right? So I will document that problem, and then I will do research so that that problem is solved. The purpose, the aim of research is to solve the problem by developing a certain theories so that they can be harnessed to solve that problem. Second, development of generalizations, principles or theories, right? There again we have certain theories based on again different experiments. So we will develop generalization. Generalization means, suppose I have done certain experiment at Delhi at IRI. So can that experiment, the results are valid for Tamil Nadu region? Can the results of that experiment are valid for UP region, other regions? If they are valid, then it is generalized. For example, the Newton laws, the laws of motions, Einstein's work, theory of relativity is true to the whole globe. It is not only true in India, but it is also true in USA. People can across the globe, but across the whole galaxy, can generalize. It is true, these laws are true everywhere. So generalization, the more generalization are your theory or your experiment have, the more valid results conclusions are. Okay, so development of generalization, principles and theories based on experience and evidence. Now experience, researcher has his own experience. So these Einstein, Newton, they have developed theories based on their experience. They have failed many times. Thomas Alva Edison has failed many times, but those failures has given him a very rich experience. So on the basis of experience, now the variables at the last time, at the successful time, the variables which he have taken has given him good results or true results, and they have propounded a theory. So it is based on the experience of the research and evidences. Evidences means the information which we are collecting in form of data, right? Demands observation skills. Without observation, how you will take data? So observations in extension, we have a certain observation skills in focus group discussions while doing PRA. So we observe each and every phenomenon in social sciences. So observation is needed in pure sciences, in laboratory work, also in field work. When extension scientists are field, observation is needed. And description, we will describe each and every variable. Gathering of data from primary and secondary sources. What are primary sources? Primary sources, if I am collecting data from the very source, right, from my lab. For the first time I am collecting that data from my lab, when I myself or my team is regulating the temperature, pest population, and the data which is originally generated are primary sources. Secondary sources means if that research work has been already been done by some other scientist, I am referring their research paper, I am referring their data for getting experience or for getting directions in my experiment, then it's become secondary sources. Okay, it requires expertise. Obviously you need expertise, patience, and unhurried activity. So research is an unhurried activity. There has been cases where research has taken so many years, then at the end they have discovered one that thing which has given them Nobel Prize and which has created history, right? So it needs expertise, patience, and unhurried activity. It is recorded, obviously it is recorded in registers in form of data, and then Excel sheets for analysis, and then research papers and books are coming out. So it is being recorded and reported, and strong determination is needed for doing good research. You all know the history of Thomas Alva Edison, Einstein, Newton, these all scientists, and the great mathematician Ramanujan from our country, Jagdish Chandra Bose. There has been great stalwart and researchers in our country. So how strong determination they have. For example, Dr. APJ Abdul Kalam, so much of research he has done in nuclear physics, and he has made our country missile dependent, right? He is the missile man of our country. So strong determination is always needed for conducting good research. So these are the features of research which you have to note down. And if a question comes, what is research? Define the characteristic of research. You can explain them in these like these ways which I have explained. Now this is very important, very important. What are the important characteristics of research? So don't confuse, these are the features of research, these are the important characteristics of research. Characteristics means these are the prerequisite, these has to be there. Without these characteristics, research will not be conducted as a research, and they cannot be categorized your research as a scientific method. So there are four important characteristics of research. The first one is objectivity, generalizability, verifiability, and predictability. OGVP, I have written that short term, so you can remember it. OGVP, objectivity. What objectivity means? Procedures, findings are not influenced by researchers' own feeling, values, and beliefs. The research should be unbiased, right? For example, if as a social scientist I am conducting my research on an area where I belong to Uttarakhand, Almora. So I am, if suppose I am having a project in Almora, Uttarakhand region, and if I am doing research on performance of my research project on people behavior, so I belong to that region. Even if people are not so innovative at that place, so what I can do, I, because that research is from my place, I will say think that, oh, these are the my people and I belong to that people, I should show them in a positive spirit. So even I will the constants and the demerits of that area I will show in a positive way. So what I am doing, I am fabricating my research, I am not being unbiased. So the first thing a researcher has to maintain objectivity. That's why your ARS mains copies, UPSC copies, only roll number goes to the examiner, not the name, because there is a risk of losing the objectivity. If I will see name from a particular caste, from a particular region, so the examiner can be biased toward that person because that person belongs to that his region. So to avoid these type of things, unbiasedness, objectivity is the first characteristics of research. So how it is maintained? It is maintained by the strong will of the researchers and by accepting a good research model, so that there is no chance of losing the objectivity. So objectivity means a researcher should be unbiased. Researchers and findings should not be influenced by the researcher's own feeling, right? Own feeling. There is a term, if you remember my communication module, I have told you there are certain barriers of communication. There we have studied stereotyping. Certain persons who are coming from a particular region, we have a certain image of those persons, right? So that is again we are drawing conclusion on based on our feelings, so that has to be avoided. Objectivity. Now second is generality. Generality means it the research, the conclusion drawn from the research should be generalized from particular phenomena to broad phenomena, right? Because the research we are doing in IRI, it should be, if we are doing research for a whole country, suppose there is a research problem, or we have developed a particular rice variety, so not only it should perform in Delhi in our experimental plots, but it should be generalized, it should perform in those areas where basmati is being grown, right? So generalizability, the more generalizability will be, the more good research will be. That's why the research done by Einstein are landmark research. They have changed the course of history because their phenomena, their experiments are not valid in a particular country, but they are true. They are true according to the whole universe. They are true here also, they are true in space also. The same law is governing the in moon also, in earth also, in every part of the universe. So that's why generability is very high. So in social science it's a big challenge to have a good generability, but still we should try that our area, our conclusions are valid for a greater area. The third one is verifiability. Verifiability means observed phenomena or fact can be verified by subsequent studies. If you have done a particular research, if the same model and the same variables, if another person is doing that research, he or she should get the same result which you have got, or they are able to verify your results. So verifiability. Today if I want to verify Einstein principles, if I have the same facilities in my research lab, same thing I will do, the same theory I will get. So verifiability. Predictability means that your research conclusion or your scientific method or your research should predict the future events, right? Predict the future events. If gravity rule says that in earth this is the gravity, so based on that principles we should be able to get the gravity quotient at moon, which we will get, no doubt about it, right? So likewise your research, if it is true for today, then according to your theories what you can predict for future, rain forecasting, weather forecasting, that type of thing, predictability is good in those type of research. So objectivity, generality, verifiability and predictability are four important characteristics of research. Always keep in mind some objective can be framed from here. Okay, so now there are three important types of research. Three important type of research, which generally broad type of research. It is not that type of research, experimental, non-experimental, laboratory, field study. That is the different categorization. So there are two categorization of type of research. The first, A part is fundamental basic research, and this part is the broad view when we see research or experiment from a broader perspective. The first one is fundamental research or basic research, the main purpose to gather knowledge for the sake of knowledge. Here we will do the basic research. For example, your basic sciences, chemistry, physics, right, botany, zoology, they do basic research, science, pure science. So the knowledge base is being updated so that on the basis of this we can build researches on allied sciences. For example, in extension, the basic research will be in field of psychology, anthropology, sociology, right? So communication, pure communication. So on the basis of that, now we can adopt research in our extension. Second one is applied or practical research. Applied research is the main purpose of this research to gather knowledge for betterment of human. You can say applied knowledge means those the researches which are based where the fundamentals or procedures of research are being applied in field. For example, extension is a classical example. Extension research, right? Practical research, we are going into field, practically we are seeing the problem and practically we are solving that problem. So we are doing an applied research, or we are applying the research which are being proposed by the basic research. So the findings of basic research are getting applied in second category of research. Then adaptive research. Adaptive research is where research which is socially useful should be conducted in situation where people live and work. On farm research, right? Adaptive research. So the research which has come up from basic science or practical research, now you are modifying that research, making the conclusion of research customized for so that it can be suited to a particular area, customized problem in a particular according to that the local resources of that village. Then we can categorize it as adaptive research, or also called as on farm research. So this is the examples. I remember this, I have compiled from GL Ray and Sagar Mandal book. It is giving in that book, from there only I have made these notes. So fundamental research example is discovery of nitrogen, right? Nitrogen is being discovered as one of the crucial element for fertilizer application in our crops. So discovery of nitrogen is fundamental basic research. Now the applied research on this discovery will be development of process to manufacture nitrogen fertilizer. Nitrogen as an element has been discovered. Now we want to have manufactured that nitrogen, so it is applied or practical research. Now what is adaptive research of this? Determining time, dose, method of application of nitrogen in rice crop will become a adaptive or on-farm research. So this is wonderfully explained. This is a classical example: discovery of nitrogen, basic fundamental research. Development of manufacturing nitrogen process, applied to practical research. Determining time, dose, method of application of nitrogen in rice or in other crops is adaptive or on-farm research. So this is the first categorization of research. Now Coming to the classification of research, which is the most important classification of research, and many questions, and you can say now we are entering into the main crux of research methodology, main part of research methodology, classification of research, B category. The first classification is experimental research and second one is non-experimental research. Now one by one we will look. The first one is experimental research. Experimental research. So what is experimental research? In experimental research we see relationship of variables. Certain variables are controlled and their effects are examined in other variables. Whenever we talk about experimental research, image should come in your brain of laboratory. If you remember Shaktiman episode, I have tried to remember these concepts like this. Experimental research, whenever experimental research is coming, I have always Dr. Jekyll is coming in my mind in Shaktiman. Right, he used to be going to a laboratory, he used to control temperature, pressure and other things so that he can develop a new disastrous element which will work against Shaktiman. So experimental research means Dr. Jekyll. So the experimental research in laboratory, we are controlling certain variables. For example, temperature, pressure, I am controlling. Now I am seeing its effect on my dependent variable, on my pest population, on other things. So one variable will be where on which you are seeing the effect. And other set of variable will be the variables which you are manipulating, where you are doing certain changes so that you can have an effect on dependent variable. So this is experimental research. Okay, experimental research, right? So the first sub part of experimental research is laboratory experiment. So question can come, laboratory experiment is an experimental research. Name is suggesting laboratory experiment, it is being conducted into lab. So laboratory experiment is a part of experimental research. Now let us look into laboratory experiment. In laboratory experiment, some variables are manipulated. The variables which are manipulated, the variables where you are playing, the variables where you are changing the intensity, the quantity of those variables, where you are controlling those variables, where sorry, not controlling, but where you are changing the amount of those variables. So some variables are manipulated, they are known as independent variables. Some variables are controlled. Controlled means for a particular research, if you want to see an effect on a particular variable, then there are n numbers of variables which will affect that variable. So from those n number of variables, there are certain variables which you want to see the effect. These are desirable variables. That's why they are known as independent variables which you manipulate. But there are certain other variables which you don't know, or even if you know, you cannot control, but they will intervene in your experiment. They will spoil your experiment by giving their effect also. If I want to see the change of temperature and pest population, so I want to manipulate only temperature, but pressure, but humidity is also playing a role. I am only interested in seeing the change in temperature and change in population, so I am concerned with temperature. So temperature is my independent variable, but pressure, humidity, other thing are also intervening in my experiment. So pressure and humidity will becoming extraneous variable. What I have to do, I have to control it. जैसे हैं वैसे ही रखूंगा. So I have to control it, so it will become controlled variable. So the variable which you are controlling, so that they will not affect our dependent variable, they are known as extraneous variable to get an effect on dependent variable. Okay, so these are laboratory experiments. So laboratory experiment means variables, independent variables, extraneous variables, dependent variables. Whenever variables term is there and we are controlling it. Variables are also in social science also, don't get confused. But the way we are controlling here in laboratory experiment, we have full control on those variables, but in field study we will see the differentiation. We do not have 100% control. So here we are 100% control on independent variables, extraneous variables and dependent variable. So it becomes laboratory experiment. So if you look into the important points, so the first one is laboratory experiment have a high internal validity but lack external validity. Validity we will cover when we will study validity and reliability. But here you can understand, since we are able to control all our variables, we have full control over our variables. So the findings of the laboratory will be very valid whenever there is an environment like lab. Right? In lab, I am controlling temperature and seeing the pest population. So in lab always I will get the same result again and again because I am able to control the temperature fully, but lack external validity. So laboratory experiment has low external validity. They do not have too much of external validity, because external validity means when this crop I have shown in field and now temperature is being regulated automatically by nature, so pest population will increase up to that level or not, which I have found in my experiment, we cannot say, because in field situations are different. In field all other variables which I have control in my lab are not getting controlled in natural phenomena, so there I will not get the same results which I am getting in my lab. So that's why laboratory experiment have high internal validity. Always remember, laboratory experiment have high internal validity but lack external validity because of control over extraneous variable and manipulation of independent variable, which you are able to do inside lab only. In field you are not able to do it, right? So we cannot make generalization with full confidence. So if my temperature is increasing and pest population is increasing in my lab, so I cannot say 100% it will happen in field, because in field pressure, relative humidity, rainfall, soil type, soil structures, other crops which are grown into that periphery of crop also affect the pest population of that crop. Okay, so we cannot make good generalization with full confidence in this on the basis of laboratory experiment, especially in case of agriculture. So there is a lack of strength of independent variable. That's why they are saying there is a lack of strength, because independent variables you are able to control in lab, but in field you are not able to control it. There is artificiality of research situation. Obviously in experiment in lab I have done. That's why if a variety is released, it has to be checked in different checks. So that's why only laboratory experiment has been done, then suddenly variety will be released. No, once variety is bred, then it has the research experiments are conducted in different areas. It is tested, validated, demonstrated, its yield is compared to the previous technologies. So that's why it's a lot of time, 9 or 10 years are taken to have a good one variety, because it is tested across the different situation, and once it is proved that it is performing in field also, then only it is released, so that the artificiality and the lack of independent strength should be minimum as much as possible. So please remember, from laboratory experiment, high internal validity and low external validity, and the laboratory experiment are conducted to discover relation under pure conditions. So where laboratory experiment will give good results? In physics, in chemistry, where the variables will behave in the real world in the same way where it is in laboratory. To refine theories and hypotheses, laboratory experiments are done. So laboratory experiments are limited in agriculture, especially in social sciences, but biochemistry and agricultural physics, soil chemistry, they are also doing good laboratory experiments. Now, the second, now also I have compiled notes from another book, Cullinger. So these are the notes first. These are the notes from GL Ray book, and now these are the notes from Cullinger book. So from this module, if you are noting down sincerely, then you will be getting good notes of both the books. So laboratory experiment from Cullinger book, if we explain, so laboratory experiment is a research study in which the variance of all the possible influential independent variable is kept at minimum. Here variance means the variance which will affect our experiment, right? So that if the variance in those independent variable itself is low, then only the variance which we will do, the data which we will change, the intensity, the quantity of the independent variable which will change will give an effect on our dependent variable. So we can manipulate one or more independent variable under controlled conditions. So under controlled condition, again the same thing they are also saying, control condition is there. So we are able to manipulate certain variables which are known as independent variable. So what is the strength of laboratory experiment? Complete control. If I want to regulate my temperature, I will be doing it. If I want to regulate the pressure, I will do it. That's why we have a complete control, because the situation is inside the lab. Element extraneous influence. Extraneous influence, I have explained to you, those variables which will affect your dependent variable and which you are not considering under your research problem, which you don't want to influence our dependent variable. So that's why you exclude those variables, and you control those extraneous variables. Researchers can use random assignment and can manipulate according to his experiment, random assignment, so that no partiality is there, no biasness is there, so high specificity will be there, precision will be very high, replicability of laboratory experiments are very high because they are under controlled environment. What are the weaknesses are lack of strength of independent variable, because in laboratory and in field, right? So both are different situation. In laboratory you are able to control the variables, but in field you will not able to control. And once there is a lack of strength and independent variable, so generalizability will also be low. Then artificiality, right? In experiment lab, you have done that experiment, it is not 100% sure that there is the technology or your experiment will perform in field also. It has high internal validity and lack external validity, which I have already explained to you. Same thing is repeated in both books, but it's always good to have notes and from two books, so that you will get diversity of the material, you will get diversity of the languages, you will get new words to write. So that's why I have compiled notes from both areas. So purpose of laboratory experiment, they will discover relation under pure and uncontaminated conditions, testing the prediction derived from theories and other research, refine theories and hypotheses, test hypotheses derived from theories. So here you should able to answer laboratory experiment, what are the important points of laboratory experiment, and what is experimental research, which laboratory experiment is a part of experimental research. Now the second part is the field experiment. Field experiment is also a part of experimental research. The field, the difference is only between laboratory experiment and field experiment is the field experiment is done in field and laboratory experiment is done in lab. So field experiment, if you have seen your agronomy professors and scientists who are working into field, they are laying out, they are doing experiment, randomized block design, CRD and other experiment on field on different crops. These are field experiment. So now let us look what are field experiment. A field experiment is research study in realistic situation in which one or more independent variable are manipulated by controlled condition. Same thing which you are doing in laboratory, you are doing into field, but it is field, that's why it is not laboratory, that's why it's a realistic situation. And here also you are able to control certain independent variable. However, the intensity of controlling those independent variables will be low as compared to laboratory experiment. In laboratory experiment you will 100% control those variable, but in field variable you will not able to control 100%, but up to certain content, up to certain percentage you can control those independent variable, you can manipulate. So you can say laboratory experiment 100% control, in field experiment control according to research design, and you can attain a good control but not 100% control. So laboratory experiment has maximum control, field experiment has less control. Clearly laboratory experiment has maximum control, 100% control, but field experiment has less control as compared to laboratory experiment, because it is in the realistic situation, field situation, where n numbers of variables are affecting our research diagram. So field experiment, it is a research under realistic situation in which one or more independent variables are manipulated under control condition. When the researchers manipulates one or more independent variables in natural settings, okay, field experiment is done in real situations, so better generalization can be made. Now this is important. So generalizations will be more valid in field experiment because these experiments are done in field, not in lab. So we are doing in field, that's why they have good generalization other in for other fields, for other regions also. Field experiments are mainly used to test broad hypotheses and theories and to answer practical questions. Obviously practical questions are answered when we do experiment in fields, but the effect of independent variable may be contaminated with uncontrolled variable. I have always explained, because field experiments are being done into real field, so there are many variables which can affect or spoil our experiment. So strength क्या है? What are the strength of field experiment? Variables in field experiment have a stronger effect than the laboratory experiment, because in laboratory experiment it is not a realistic situation, it's a lab situation. But in field experiment, the results which will come will be more valid, will be have a stronger effect, because you have done the research in field. That's why field experiments are always preferred until unless the laboratory experiments are based on pure sciences. So more valid generalizations can be made on field experiences. They are most appropriate to study complex social influences, especially in extension education process, changes in life process like sociology, educational setup. So all the research which we do in social sciences, and they comes under field studies. We will also study those field studies. So these are field experiment. Don't confuse between field experiment and field studies. Field studies we will cover in next module. Here we will look into field experiment. So in social sciences also field studies are also there. Up to certain extent field experiments also there, especially in educational research. In educational research, suppose a particular group of student we are, or a farmer, we are disseminating technology with one method of extension. In other we are disseminating technology another method of extension, and then we have a control also. So we can have a field experiment in extension also, but they are very less or very few people are doing this type of research. So field experiment, you always good example is agronomical experiment, soil science experiment in fields. Laboratory experiments are physics, chemistry, biology, geology, biochemistry, agricultural, soil science, chemistry. The pure research which are going in experiment is laboratory research. Okay, so in field experiment well suited to test theories. Flexibility, yeah, it is in field, so we have good flexibility and applicability. Weaknesses of field experiment are power of manipulation of dependent variable low, because you are working in field, you cannot control each and every variable up to 100%. Manipulation of independent variable and randomization are two most important problem. Obviously, how you will manipulate independent variables in field, it's very difficult to attain, but still there are good researchers which are being published in research paper. That's why the regression model and the percentage of effect on dependent variable we calculate by research methodology. Okay, so manipulation of independent variables and randomization are two important problems. Lack of precision, because in field we do not know how many other variables has affected our experiment. So laboratory experiment is conducted in tightly controlled situation, while field experiment take place in natural and often loose situation. Okay, so this is very important to understand. So field experiments have flexibility, applicability. Randomization cannot be used in field experiment. In field experiment there is a lack of precision, you can write it down. So here you can find it. Okay, so today we have covered experimental research. In experimental research we have seen characteristics of experimental research, then we have talked about laboratory experiment, what are the important characteristics of laboratory experiment, and then we have also seen how field experiment are conducted, what are the important characteristics of field experiment, and how field experiment are different from laboratory experiment. So experimental research has two important part, laboratory experiment and field experiment. So in next module we will start our module from non-experimental or descriptive research. What are the different type of non-experimental research? So I hope you had liked the session today, so stay tuned. So I will be very regular now and I will be uploading modules regularly, so stay tuned with my channel and post your comments. Your comments are very precious for me and I'm trying hard to cover the full syllabus, especially that's why I have started research methodology, because many students have requested to start research methodology because they are finding difficulty to understand. So from these modules you are getting my notes also, you can make your own notes, you can revise also. And now only 1 month is left for your ARS pre. Focus on pre, listen to my modules, revise from your notes and solve objective as much as you can. So we will meet in next module and we will cover the remaining parts. So research methodology is a unit which is a quite long unit, so I will cover one by one systematically and will try my best to explain and clear your doubts. So okay, all the best, thank you so much.